Words of background. I come from the industry as an entrepreneur. I led a company that was doing an LED optical packaging with a lot of work both in Asia, Singapore, Taiwan, Korea, Japan, and a lot of work in China. And there's a huge LED industry in China, which is growing fast and beautifully. I also led a few companies in the space of software, and I'm personally an author of 18 patents. That's my personal background. And with the, I'm working with Yael in the Nano Center, and we came to the understanding that we need to try and stimulate and work with the brilliant professors in the center to try and understand what is done in their labs and confront it and come with the right questions and direct them into how to start building the companies. So first of all, it's selection. There are hundreds of beautiful and interesting projects in the university. Only a few of them can become a company, right? Only a few of them are worth, again, commercial, not from the scientific point of view. There are brilliant people, and the science could be phenomenally brilliant, but in terms of bringing that to the market and creating viable and sustainable companies, it's not trivial. So selection is very important, and my role together with Yael is asking the right questions. Is there a market? What is the time to market? What is the capital needed to come to this market? And smartly build prototypes that can be effective and impact the market, meaning illustrate and demonstrate to the market there's a potential. Again, the professors are dedicated and with a view of pure science. The market out there is on the applied side, and build the bridge between the science and the applied version or the applied needs is, again, the filling of my task. The market-oriented demonstrators, I think, is the place where it's interesting to speak with people that come from China and the Chinese market, meaning, again, to spend every dollar in a way that when you present that to venture capital or strategic partners or to customers, you can convince them that what you have just presented is viable, meaning it has a fundamental science background, meaning it has an IP protection, it has something that can create a quantum leap or a jump leap into a true innovative product from one side, but it's manufacturable in terms of current manufacturing processes and will have an end price. So speaking with professors about an end price of a product is not a trivial task. And I brought two examples, and luckily one of the professors I've worked with, Professor Yossi Shachem, is also here in the room. So it's my pleasure to present two projects which I think are pretty interesting and luckily are also being funded as we speak. The first one comes from a need, and the need is cooling. And cooling is required in many places, mostly in mobile devices. Just a week ago, Sony announced $500 million losses. 100 million of them came from the losses of the Vaio laptops who failed on a thermal side. Just $100 million went down because of thermal problem. Here's the need. We need to cool ultra-thin laptops. How do you do that? And I came across two brilliant professors, Professor Yossi Shachem and Professor Slava Krilo from the university, and it was not even a work that they would do. It was a paper they wrote which triggered my imagination, and we sat down and while identifying, I think, hopefully, clearly the problem, we started working by coming from the science, the product, the capabilities of what they're doing in their labs, and I was asking the tough questions. Can we move air fast enough? Can we remove enough heat with this specific product? Can we bring that to a low cost? Is that easily integrated into the manufacturing line of Sony or other customers? We already have the first customers even before we funded the company. Is it efficient enough? And what was more important, we started by saying, can we create a fan, a cooling fan, which is less than a third of a millimeter? So with the brilliancy of the professors, we can now come to a potential customer and say, imagine that you have a fan which is a third of a millimeter, which is extremely efficient, which is low cost, and again, it's not there yet. but we can stimulate the imagination of a potential customer, of a potential investor. I can wave my hands fast enough, they can support that, and together you create something which hopefully you can come to a customer. Luckily, this triggered the imagination of two kinds of customers. When we came to one of the world's largest car manufacturers, we found that there's a true problem which is bigger than the laptops. Cooling of electrical batteries of cars. And currently we're just signing an agreement of the first prototype with one of the largest car manufacturers in the world. He was supposed to be with me in this panel. They have an office here in Israel, and join me and present this, but he had, the CTO is here as well. And so we're doing the first proof of concept with a car manufacturer, illustrating that we can cool a car battery. And the challenge in a car battery is very similar to laptops. There's a thick a gap of less than 5 millimeters between the cells in a car battery. And again, going back to this slide, all of those features, which were a question I asked the professors, they came up with, hopefully what are smart answers, yielded in the first product and the first customer. So we identified a few markets for this ultra-thin fan. Mobile devices, LEDs were the industry I'm very familiar with, laptop computers, and electric car batteries for cars. And luckily, it seems to be triggering the imagination of some relevant people. So the process was selecting, first of all, selection, finding the people that had something that the market might need or may need or potentially need. And it could be an idea, it could be a lifetime work, it could be a paper. I don't know, it can come in various ways. It can be a coffee discussion. So the amount of coffee I spent with Professor Shacham and Professor Krylov is identical to the amount of time I spent reading their articles. It was easier to drink coffee with them. It's pretty challenging to read the stuff that you're doing, but eventually we came up with this idea. So this is the first example of the work that was, again, supported by Yael and led by her. The second thing comes from a completely different direction with Professor Shachar Richter. And here is a beautiful example. I'm an avid scuba diver, so this came from a interesting and personal interest in this. So jellyfish are a threat to the oceans, right? That's the need. Can we do something with the jellyfish? So there is a usage of jellyfish in the food industry, but it's not enough. It's tasty. I did it. In Dalian, most of the time I spend in Dalian, and there's great food there, but it's not enough. In the coastal cities, in Japan, Korea, around Jeju Island, around some areas in China, this is a severe problem. So Professor Richter came with the idea, let's do something with this. And the something was, let's create an absorber, all right? Let's use this plastic bag, this oceanic plastic bag, to create an absorber. So we started thinking, all right, so we can absorb what? We can absorb water, we can absorb fluids, we can absorb all kind of stuff. So we went out to the market, and we came up with the idea of bringing absorbers, either as a hydrogel or a powder, for the beautiful and very interesting market of hygiene products, diapers and others. So we are solving, or I don't know if you can say that, but we're killing two birds with one jellyfish. Both taking the jellyfish out of the ocean, which is a desired task, whilst doing something very positive with that. It's extremely challenging. Will the Johnson & Johnsons of the world, or the Hitachi or the other chemical companies will adopt it? It will take time. It's not a one-year project that they will adopt it. Will the end user agree to use those kind of devices? We don't know yet. We just know that it is solving a huge problem. It has phenomenal features of absorbing blood that none of the super absorbers, the SAPs, do not have. It's biodegradable. 30 days after usage, it's gone. So in small countries, Japan, Korea, where putting the diapers away or the hygiene products away is a huge issue. It's less of an issue today in China, but in smaller countries, that's a huge issue. So our absorption of both fluids and blood is a phenomenal feature of this device. And again, this is a very scientific project, but we've been able to show not only that it's holding blood, it is fighting some very challenging and harsh environments. Can this resist the body weight? We don't know yet. Can this hold the blood or with pressure? We don't know. But we do know that we can manufacture a super absorber in extremely low cost, and we're now in discussions with the Korean government that will give us money to build a plant. So we are getting governmental money to do something with this. We know that there is a huge potential in building that, bringing that to the market, and we also know something very critical for this discussion. This is an innovation from Israel, extremely relevant for Asia. Right? The factory for this company will be in Asia. Be that in Korea, be that in Japan, there's no problem of jellyfish in Taiwan. Be that in China, be that in Australia, but that will be either in Asia or Okinawa or that area, that's for sure. So these are two great examples, to my opinion, of brilliant scientists, brilliant science, hopefully reasonable questions that were asked on the commercial side, and eventually we came up with products, right? It's not a paper, and there are papers, and the professors are doing their brilliant scientific work, but we have something that we can now work with. In this case, we're negotiating deals in Korea and in India, and in the previous case, we're doing something which is even more advanced than that with leading car manufacturers. So for this beautiful group of people from two very distinct countries, different in size, different in motivations, different economical resources, what I think is unique in this program, again, and with the vision of Professor Hanin, is that we look into the innovation here with the view of the largest markets. So it's answering the question of both innovation and entrepreneurship. It's the professor's job to bring the innovation, and my job to bring the entrepreneurship in order to create something that will have an impact. That's my story.